Hey everyone, it's Mrs. Slauson, and we are in the pink packet. We're going to be covering our last section, so 4.5. I am on page 62. I've already done some writing. I had started the video, and then the bell rang, and it messed up, so it's starting over, and I don't have a free packet to work from. So some of these things I'm just going to talk about as you see them. So in our last section, what we did is I gave you a function, either in factored form or in standard form, and then we were able to work with that function and graph it. And when we graphed it, we paid attention to the end behaviors. We paid attention to if it bounced off the x-axis, wiggled its way through the x-axis, or crossed its way through the x-axis, and we also focused on the y-intercept. So we're going to do all of those things today. But we're going to take the graph and now write the equation, okay? So this is what a reminder up here. It does say here, find the equation of each of the functions shown below. Assume that no zero has a multiplicity greater than 3. That just means when we're looking at the bounce, wiggle, cross, that the highest amount of time any answer is ever going to show up is 3. Don't do any more. So our biggest odd number will be 3. Which means our biggest even number will be 2, and then 1 falls in there. So remember, bounce, if it answer shows up twice or an even amount of times, it's going to wiggle when it shows up an odd amount of times, but we're only going to go for 3 as our biggest odd number, and then it crosses when your answer shows up once. So what I want you to think about first is the shape. This is a bumpy line. So that means in the end, if I were to look at this in standard form, for instance, the highest exponent would be an odd number. I also want to realize that the leading coefficient, the number in front, would be a positive number because this line in the end is going uphill. All right? So that's why you see this written there. The next thing I looked at are my zeros, and I paid attention to a bounce. So bounce means it shows up an even amount of times, but our biggest number will be 2. So I wrote -2 twice. And then at 3, it crossed, so that's just once. And then from there, I will keep in mind this y-intercept as I started to write the function. So I will be squishing something in there in just a moment. So if you wrote with pencil, maybe just pause or erase or hold on, because something is going to go in here. So let me start with the end. The factor that would have given me 3 would have been x minus 3. Since it crossed, I only show this showing up once. So I could put a first power there, but they don't usually do that. This -2 bounce, so that's why you see 2 -2's again, because of the bounce. So the factor that gives me -2 is x plus 2, and because there's 2 of them, I could write 2 separate parentheses. You can, or you can just write x plus 2, and the squared says that there's 2 of these. I will have to keep in mind a y-intercept, because right now, if I put 0 in this, I'd get 0 plus 2, which is 2. 2 squared is 4. So I'd get 4 from here. And if I put 0 in here, I'd get -3. And 4 and -3 doesn't give me this as a y-intercept. So that means there is some a value hanging out here in front. Okay? So that's kind of the general format. And what we'll need in the end is to figure out what that a is. So to figure out that a, what I'll do is take the extra point that they gave me, and we've done this before, and I'll put this in for f of x, which is y, because that's my y value. We will do some math to figure out a, and then for the x's, I'll put the 0, and then what I'll do is I'll solve for a. So if I just kind of draw a wall here, I'm just cleaning this side up. So 0 take away 3 is -3. I'm going to keep it in parentheses. 0 plus 2 is 2, and 2 squared is 4, so I'll keep 4 in parentheses. And then I have an a with the -3 over, and then I'm just going to multiply this up, and I get -12a. And now to solve for a, I would just divide by -12, and that simplified is a fourth. So when I'm done, I get a to be 1/4, and then I can write the equation. So essentially, I just have to go up to here and replace that a with the 1/4. But if I write it just all over my function, a would be 1/4. I would do x plus 2 squared and x minus 3. And if I want to see if I'm right, the graphing calculator is really easy to use. I'm typing in it right now. And what I could do is see the way it looks, and I could also go to the table and just check it out. So when I wrote a fourth, I put it in as a decimal. So one I can just see, does it kind of look like my picture? Here's Zoom 6. I hope it does. Looks just like it. Or I could go to my table and just see, you know, is -2 a 0? Yes. Is -3, whoops, you can't see that with that glare, a y-intercept? Yes. And this 3 is 0. But in this case, the picture's a good thing to look at. So I got my final equation in black. So let's go to the next one. So this one is a bumpy line. So I do know that in standard form that my highest exponent would be an even, and there's some negative number hanging out in front. So I want to keep that in mind, and now I want to look at my factors, my zeros, and see how many times they show up. So again, -2 is a bounce, so that is showing up twice. 0 is a cross, it's showing up once. And then this is what we call a wiggle. So 2 is showing up 3 times, okay? And then they do give me some other point for now, which I'll be using. So working my way just this way, the factor that would have given me 2 is an x minus 2. And this is an odd amount of times, so I'll put a 3, because again, I don't want bigger than 3. Now I'm going to put the one for, I'm actually going to do this one next. I have -2, so that meant there was a squared. And the factor that gave me that is x plus 2. And I just like to put the single one on its own, because the factor that would have given me 0 is the x. So this factor gives me -2, this factor gives me 2, and this factor gives me 0. If this had been a bump, for instance, I would put a squared. But right now, what I want to do is solve for a. Okay, so I'm going to put an a in front, and I'm going to put a y here, and we're just going to figure out what that a is. I'm not sure exactly what it is. It might be a 1, a 2, but what I do know is that it's negative, and so I have to solve for a. So from there, I'll just take this other random point that they give me and put this in for y, leave a alone, and I'll put 1 in for x. And then I'll do the math to figure out what a is. So I'm going to draw my wall, and I'm just going to clean up the side. So this is -1, and -1 cubed is -1. This is 3, and 3 squared is 9. And then I have the 1, and again, these are all multiplying. And then I have the a with the 2, and then I'll just multiply. So when I multiply all of this, I get -9 with the a, and then to solve for a, I just divide, and it's not a pretty number, but that's okay. So a is the -2/9, and then I can just come back up here and replace it, and then that's the equation. We're not solving for a, we're solving for a so that we can have the equation. So that's a 9. I'm going to put this x in parentheses now. Not that you need it. And then, that's a 2. If I go to my graphing calculator and put this in, I should see how that looks. So I'm going to pause for a moment and get that typed in. So real quick, let me show you how I type that in. Because I'm putting in a fraction, I did put that fraction in parentheses, so my calculator knows it's a fraction. Then I just did x plus 2 squared, x minus 2 cubed, and then you can see it graph here. Well, it will graph here. There you go. And look how close that looks to it. I mean, this is a little more zoomed in, but there we go. All right, so let's try some that don't have the picture. So in this one, we're going to find the equation of f of x. It is a 4th degree polynomial. So that means in the end, my highest exponent will be a 4. And here are my zeros, x equals 2, x equals -4, and a repeated 0 of x equals 0 with a multiplicity of 2, which means 0 showed up twice. So I'm going to start by making the factors. They do want this one in standard form. Okay? So I'm going to put my a in, my factors. So what would have given me that is x minus 2. What would have given me this is x plus 4. And then what would have given me this are 2 more x's, an x and an x, which just turns into x squared. Now, in this one, I realize it's probably missing some directions. It should say assume that A equals 1, because I can't figure out what A is unless I have some other random point, like they gave me here, and like they gave me here. So because I don't have that random point, we're going to assume that A is 1, and we won't have to solve for it. So here is the equation in factored form, right? To get in the standard form, I just need to have the neighbors meet. But I got to remember that there's 3 neighbors, 1, 2, and 3, and only 2 neighbors can meet at a time. So let's just say we start with the x squared and the x. So when those neighbors meet, I get x cubed minus 2x squared. And now that group can meet the x plus 4, and I'll have x cubed meet x for x to the 4th. I'll have x cubed and 4 make 4x cubed. Then these neighbors meet. Whoops, sorry, you can't see that. Let's see, where am I? There's another x cubed, and then when I'm done, I have a minus these neighbors meeting 8x squared. So again, I got x to the 4th, I got 4x cubed, I got minus 2x cubed, and then I got minus 8x squared. And then I'll just combine these like terms. And I would get my function. So I started with y. It actually said f of x, but oh well. Okay? All right, last one. This is our challenge problem. So there was an extra credit video that I showed at the beginning of the year. This is a challenge problem, and it's not necessary to watch, but maybe some of you want to. So throughout all the examples throughout this year, you should notice that if your function has real coefficients, then complex and imaginary zeros start to pop up, become what we call conjugate pairs. And in other words, it's known that if this is one of the zeros, then this is its like pair, its partner. And a conjugate just means that the only difference between this factor and this factor is that there's a plus and a minus. Okay? So what I'm saying here, and maybe I should back this up a little bit, it's just saying that, well, I'm just going to go here on the next page. And again, this is just a challenge problem, just throwing it out there. So we're going to find the equation of a cubic polynomial, so the highest power is a cubed, with real coefficients that have zeros of -2. So this is 1, 0, and what the other side was, sorry, you can see that, and what the other side was saying is that if you have a 0 worth 4i, then you actually have another 0 that they're not going to point out to you of -4i. So that's what it's saying, all right? So here, we're going to have a 4th degree polynomial in a moment. So our highest power is a 4th power. And they're going to give us the real zeros, 3 and -3. But if they give you a complex 0, they always leave one out. So they're leaving out that there's just an I. All right? And then on this one, they'll give you all the real zeros. But when they start to give you an imaginary one, they're leaving out the other one that goes with it. There's always a positive and a negative of them. But since we don't graph imaginary numbers, they usually don't worry about writing them both down. All right? So what we're going to do is we're going to write the factors for this, and then we're going to turn it into standard form. So the factor that would have given me this is x plus 2. A factor for this just would have been x minus 4i, and a factor for this would have been x plus 4i. And then you just have the neighbors meet the neighbors. So before we do that, let's just go to this one. A factor for this would have been x plus 3. A factor for this, sorry, that would have been x, that will be x plus 3. That will be x minus 3. I switched them around. This would be x plus I. And this one would have been an x minus I. And then I'd start to have these neighbors meet, right? And then for this one, I would have had an x minus 2, another x minus 2, an x plus 3i, and then an x minus 3i. So this is the start in factored form, and then I would do some other work. So let's just go through these. So starting at the top, I need to have the neighbors meet the neighbors. When in doubt, I would have these neighbors meet first. So I'm going to get an x squared. And then I'm going to get a 4i with an x. And then here I'll get a minus 4i with an x, which hopefully you see that those will just cancel out. And then when I multiply these, I get a minus 16 with an I squared. Oh boy, we're going to just ignore that. Hold on. Okay, sorry about that. So now what happens is this was a capstone question that we practiced in class. You do need to remember that I squared is worth -1. So when I look at this negative 16 multiplying the I squared, that's like negative 16 times -1. So this whole thing becomes a positive 16. So those cancel out. This becomes positive 16. So right now I have x squared plus 16. And now I'll just bring the last neighbor in. Oops, I didn't need double parentheses to meet this. So starting, I'm going to get x cubed. I'm going to get a 16x. Then I'm going to get a 2x squared, which technically standard form, those should switch places. And then when these meet, I get 32. And then I can write whatever function I want. Okay? Now, they didn't give us another point, so if they don't give us another point, we just assume that a is 1, which I should have probably said that in the beginning. So let's go down to the bottom one and just walk through this one. So first I need all the neighbors to meet. So I'm going to have those neighbor meets, and then those neighbors meet, and then I'll bring that group together. So I'm going to get an x squared. I'm going to get a minus 2x and another minus 2x, which gives me minus 4x. And then when these neighbors meet, I get a plus 4. So those neighbors have met. So now let's have these neighbors meet. So I'm going to get an x squared. I'm going to get a minus, this one I'll write out, 3xi. But then when these meet, I get a plus 3xi. So those will eventually cancel out. And then when these meet, I get a minus 9. And then I get an I squared. And again, I want to remember that I squared is worth -1. So where this is -9 times I squared, this is now -9 multiplying to -1, which is a 9. And then I'm just left with, because these have canceled out, x squared plus 9, which now can meet this neighbor, which I'll just put behind it. And now this neighbor meets this neighbor. So we start, you get x to the 4th, you get a minus 4x to the 3rd, and you get a plus 4x squared. And then this neighbor meets, so we get a 9x squared, which I like to stack with the other x squared, because I'll have to combine those like terms anyway. And then I get a minus 36x, and then I get a plus 36. So when I'm done, this is x to the 4th minus 4x cubed plus 13x squared minus 36x plus 36, and I should put like a equals h of x here because that's what it says. Whoops, sorry, I'm sorry you couldn't see that answer, but now you can see it. I just combined. That was the 13 and brought those things down. All right, that is all we are going to cover in the notes. This is the most challenging problem. I'm not going to throw that in our notes, just have to pick and choose. So that is our notes for section 4.5, and we are done with chapter 4.